I'm going to work through a few problems here on Worksheet 4. Let's start with number 1. Number 1, we're asked to factor the following. There are different types of factoring, and if you have 3 terms, a trinomial, where the leading coefficient is 1, we can just take a look at the second coefficient and the constant, and ask ourselves what two numbers multiply to 12 and add to -8. So you start thinking of different numbers that multiply to 12. 1 times 12, and then add them together and see if you get -8. 2 times 6, 2 plus 6 is 8. That's close. I want -8. So use the same numbers and try negatives. So what about -2 and -6? That gives you positive 12 when you multiply it, but adds up to -8. So that's what we want, -2 and -6. And so this thing's going to factor to x minus 2 times x minus 6. That's our answer. Why is that the answer? Why does that work? If you multiply this out, distribute it, we get x times x, which would be x squared, x times -6, -6x, -2 times x, -2 times -6, and so you see the -2 and -6 are going to add up to -8x, and they multiplied to positive 12. So we were looking for those two numbers so that this product would work out. Next, I want to take a look at number 9. Number 9, we also have 3 terms, but the leading coefficient is not a 1. So the multiplication is a little more complicated to figure out. What we do is multiply the first term with the last term, 4 times 3, and we're looking for two numbers that multiply to 4 times 3, which would be 12. So it could be 4 and could be 3, but it may not. But then we also want these two numbers to add to our middle coefficient, our linear coefficient, which is 13. So two numbers that multiply to 12 add to 13. So start with factors of 12. 12 times 1 is 12. 12 plus 1 is 13. So that's what we want, 12 and 1. It worked out. Here, we don't directly go to our answer like we did in number 1. There's no shortcut. We need to expand it from 3 terms to 4 terms. We leave the first term the same. We split up the middle term to 12x plus 1x plus 3. So the last term and the first term stayed the same. That 13x split up to 12x and 1x. Where did I get the 12 and 1 from? From this little game we played, what two numbers multiply to 12 and add to 13. Next, we factor by grouping. If you remember what that means, you look at the first half of these 4. When you have 4 terms, you always think factor by grouping. You look at the first 2 terms, ask yourself, what can I factor out of the first 2 terms? What is the greatest common factor? In this case, it's 4x. If I divide 4x squared by 4x, I get x. If I divide 12x by 4x, I get 3. And then look at the last 2 terms, the 1x plus 3. What is the greatest common factor of those? In this case, only positive 1. If I divide 1x by 1, I just get x. If I divide 3 by 1, I get 3. If you're doing this correctly at this stage, what's inside the parentheses will match. Take what's inside the parentheses, the x plus 3, and factor it out of both terms. When you do that, you end up with x plus 3 out in front, and we're left with the 4x plus 1. So the two x plus 3's just became 1x plus 3 out in front, and then the the 4x plus 1 is what creates your second factor. And now we've finished. We fully factored it. Again, you can check to make sure this works just by multiplying it out. If you multiply x plus 3 times 4x plus 1, you should end up with what we started with, 4x squared plus 13x plus 3. Number 11, 8x squared plus 30x. We have two terms here. One thing that's always good, no matter what factoring problem you're looking at, is to see, well, is there a greatest common factor we can divide out of all of it? In this case, 8 and 30 are both divisible by 2, and x squared and x are divisible by x. 8x squared divided by 2x is 4x. 30x divided by 2x is 15. And that's as much as we can do in factoring that. Number 12, we also have two terms, but this one's different than 11. We don't have a greatest common factor we can factor out. But notice we have a difference of two perfect squares. 25x squared is 5x times 5x. 49 is 7 times 7. When you have a difference of two squares, there's a trick to factoring this. You take the square root, 5x, and 49 would be 7, square root is that. And so you get 5x plus 7 times 5x minus 7. Opposite signs, one's a positive, one's a negative. And when you multiply that out, you end up with what we started with. That only works with a difference of two perfect squares. Number 14. Notice both terms have an x plus 1. So factor that out. X plus 1 comes out in front, and what's left is the 7 and the minus x, and it's factored. One step. Next part, number 20, we're going to look at, and we're to solve by factoring. So we want to factor and solve by factoring. When you solve by factoring, you need to make sure your equation's equal to 0 before you factor it. Notice number 20 is kind of factored already, but it's not equal to 0. So when you have that case, you're going to have to multiply it back first. So 3x squared minus x equals 4. And make this equal to 0 by subtracting both sides by 4. Then go ahead and factor. Well, this is the case where you have three terms and the leading coefficient is not 1. So we're looking for two numbers that multiply to 3 times 4, which is, pay attention to the signs. It's 3 times negative 4, which is negative 12. And we want them to add to the middle term, which is a negative 1. 12 is 12 times 1. Can't get a 1 from that. 2 times 6. Can't get a 1 from 2 and 6 when you add them. 3 times 4. Well, if you subtract 3 and 4, you get a 1. So you start to play with the signs. What should be negative? What should be positive? And if you get a negative 4 and a positive 3, it works out. When you multiply them together, you get negative 12. When you add them together, you get a negative 1. So remember, this splits it from 3 terms to 4 terms. First term stays the same. Middle term, negative 1, splits to negative 4 and positive 3. And the last term stays the same. Then we factor by grouping. The first two terms, you can factor out an x. You're left with 3x minus 4. The last two terms, you could factor out a 1 only. You're left with 3x minus 4 again. Both terms have a 3x minus 4, so you factor the 3x minus 4 out, and we're left with the x plus 1. This is equal to 0. So now when you get to this stage, when it's factored equal to 0, you can split the factors up and set the factors equal to 0 individually. So in the first case we get 3x is 4, so x is 4/3. In the second case we get x plus 1 is 0, so x is -1. So two answers from two factors. Next we're going to take a look at number 22. It's factored, but it's not equal to 0. So we need to multiply this out. So 2x times 3x, 2x times 1, 3 times 3x, 3 times 1 is equal to 3. So 6x squared plus 11x, subtract 3 from both sides, equals 0. Here we have two terms now. We want to factor them. Notice we can factor out a GCF. We can factor out an x from both of these. So x times 6x plus 11 equals 0. We have two factors, set each factor equal to 0. So x equals 0 is one answer. 6x plus 11 equals 0 is the second answer, but we need to solve for x. So we subtract 11 and divide by 6. Yeah, so we have two factors, we get two answers. 24, we have 5x squared equals 10x. Needs to be equal to 0, so I'm going to subtract 10x, and we get 5x squared minus 10x equals 0. Then factor, divide out an x and a 5 if you wish, so 5x, and we have x minus 2 left over equals 0. So we got two factors here. Set 5x equal to 0, set x minus 2 equal to 0, and solve. Divide by 5 on the first and get x is 0. Add 2 on the second and get x is 2. Two factors, two answers. Number 34, we're going to solve by using square roots. So to do that, we need to get the squared part by itself. We first subtract 1. Do not add the 1 and the 2, because that 2 is multiplied with the part with the exponent. If we followed order of operations, we'd have to do the exponent first, then multiplication, then addition. But because it's an equation, we're allowed to subtract 1 from both sides, and I'm going to do that. And I get this equal to 16, and then divide by 2. What we do not want to do is square the 2x minus 3. We need to leave it squared because we want to solve this by taking the square root. So now we're at the stage where we take the square root. So the square root of 2x minus 3 squared is equal to the square root of 8. And when you take the square root of a variable, you end up with 2x minus 3, but we don't know if x is positive or negative, and we always have to have a positive answer, so we put that in absolute value. And remember, 8 is 2 times 2 times 2. And a pair of 2's, if you multiply a pair of 2's together, you get a perfect square. So this is the square root of 4 times the square root of 2. Absolute value, which I guess I should change to 2 root 2. If 2x minus 3 could be 2x minus 3 could be equal to 2 root 2, or you could have the negative, or it could be equal to negative 2 root 2. And so in the first case, we add 3, and you get 2x equals 3 plus 2 root 2. And then we divide by 2. So 3 plus 2 root 2 all over 2. In the second case, we get 2x equals 3 minus 2 root 2. Divide by 2, you get x is 3 minus 2 root 2 divided by 2. And the last problem I want to do with you guys is number 36. 36, we just want to simplify this. And when you simplify it, start with what's on the inside of the square root. We want to square the negative 9. So that's 9 plus or minus square root of 81 minus, multiply the 4, 1, and 4 together, that's 16. All over, multiply the 2 and the 1 together. And then keep working with that square root, find out what 81 minus 16 is. So now we have 9 plus or minus the square root of 81 minus 16, which is 65. And then see if we can simplify it further. 65 is 5 times 13. And that is, both 5 and 13 are both primes. So 65 is reduced as much as we can, and there we have it.